You ever wonder how AI actually understands you? I mean, how does it take a big wall of text that you throw at it and turn it into a perfectly clear answer? Well, today we're going to pull back the curtain and see exactly how that happens.
It can honestly feel like magic, right? You upload some dense 50-page document, you ask it one little question, and boom, you get a perfect summary. But what's really going on under the hood? It's not magic, not at all. It's actually a pretty brilliant and logical process.
And this, right here, is the fundamental hurdle we have to get over. For a machine, a sentence like "the quick brown fox" isn't about animals or colors. Nope, it's just a string of characters. It has zero meaning. So to get from that digital gibberish to real insight, we need something called natural language processing.
All right, so let's start with this core challenge. How in the world do we teach a machine, a thing that only gets numbers, to understand the rich, messy, beautiful world of human language? You know, this detective analogy really hits the nail on the head. Imagine you've got this mountain of raw text, and AI needs to be your investigative partner, right? It's got to find all the patterns, the names, the connections that would take a human, well, forever to find. But before it can do any of that, it has to learn how to read. So the crucial thing to get here is that it doesn't see the word cat and think of a fluffy animal. It literally just sees C-A-T. To bridge that enormous gap, we have to translate our language into a format the computer can actually do something with.
And that translation, well, that's our first major step. We need to convert all this beautiful, nuanced human language into the clean, cold, logical world of numbers.
And this process basically breaks down into three main stages. I like to think of it like you're prepping a meal, you know? First, you gotta clean your ingredients. Then you chop them up. And finally, you cook them into something totally new.
So step one is all about cleaning house. We make everything lowercase. So the with a capital T and the with a lowercase t are treated as the same word. We also get rid of really common words. We call them stop words, like the, is. They're important for grammar, but they don't add a ton of meaning. It's all about cutting out the noise.
Okay, next up, we chop. After the text is clean, we break it down into smaller pieces called tokens. So a phrase like "fox jumps" becomes two separate tokens, fox and jumps. This way, the computer can look at each piece one by one instead of getting overwhelmed by the whole sentence. Now we get to the really magical part, embeddings. Each one of those little tokens gets converted into a vector, which is just a fancy way of saying a long list of numbers. And this isn't just some random ID number. This vector is a super rich mathematical map of the word's meaning, something the AI learned by looking at billions of sentences to see how words relate to each other.
And this is where you really see the power of embeddings. Old-school keyword matching would see solar and sun as two totally different things. But with embeddings, the AI gets the relationship. In this giant mathematical space, the number list for king is really close to the number list for queen. It knows solar and sun are connected. It's capturing meaning, not just letters.
Okay, so our words are now these powerful numbers that hold meaning. That's awesome. But in a long sentence, not every word is equally important, right? So how does an AI figure out what to actually pay attention to? So look at this sentence. As a human, your brain just knows what's important here. You instinctively know the main point isn't about delicious pasta. It's about the chef doing something. You naturally focus on the key parts.
Well, that's pretty much exactly what an AI learns to do with something called an attention mechanism. It scans the whole sentence and gives each word an importance score. So here, it figures out that chef, prepared, and dish are the really crucial words for understanding what's going on. It learns to zoom in on what truly matters.
But you know, this brings up a huge problem that older models had. If they read a long paragraph one word at a time, by the time they got to the end, they would have totally forgotten the context from the beginning. It's like trying to read a novel by looking at only one word at a time and never being able to look back. And the solution to this problem, wow, the solution was this revolutionary idea called transformers. Using that attention thing we just talked about, a transformer can look at the entire sentence or even a whole document all at once. This means it can understand the full context, connecting a word at the very beginning to a word at the very end. This was an absolute game changer.
All right, so we've got all these incredible tools in our toolbox. Now let's put them together into a system that is just dominating AI right now. It's called Retrieval Augmented Generation, or RAG for short. And honestly, the best way to think about it is as a power duo, a librarian and a writer.
Okay, so the retrieval model, that's our librarian.
Its entire job is to search through your document, that whole library of information, and just find the most relevant facts for your question. It's fantastic with accuracy, but its answers can be a bit choppy. Then you have the generative model. That's our writer. The writer is amazing at taking a bunch of facts and weaving them into a smooth, easy-to-read, coherent answer. Its only weakness, if you don't give it facts, it might just make stuff up. But when you put them together, they're basically unstoppable.
So, let's put it all together. Let's walk through the entire journey of your question, from the moment you hit enter to the moment you get back that perfect answer.
Okay, here we go. First, you ask your question. That question gets turned into one of those number vectors, an embedding. Then, the librarian gets to work. It uses that embedding to search through all the text, finding the pieces with the most similar meaning. It pulls out these key facts and hands this little package of information, along with your original question, over to the writer. And then the writer does its thing, using its language skills to build a perfect, fact-based answer using only the info it was given.
So the big takeaway here is that when you're talking to a modern AI, you're not usually talking to one giant, all-knowing brain. You're talking to a highly coordinated team, a super thorough fact-checker, and a brilliant storyteller working together. And it's that incredible partnership that turns what was basically digital noise into something that feels like